TechInFive.
Python in practice, master real-world projects in 5 minutes. Are you interested in setting up PyTorch in Docker? Don't miss out. Let's create your powerful learning environment together. Today, we're diving into setting up PyTorch in a Docker container. By the end of this video, you'll have a fully functioning PyTorch environment running in Docker. Let's get started. In our previous video, we created a Docker environment for machine learning. Now, we'll set up a similar environment for PyTorch to ensure that we have a consistent and isolated setup for our machine learning projects. Let's start by updating our requirements.txt to include PyTorch along with other essential libraries for numerical operations, data manipulation, visualization, and machine learning. Then, we run the docker build command with the updated requirements file to build the Docker image. Once the build is complete, we can start a container from the image with the docker run command. This command starts a new container with PyTorch and other tools installed. We also maps port 8888 of the container to port on the host machine, making Jupyter Notebook accessible. And that's it. We've successfully set up a Docker environment for PyTorch. We can access the Jupyter Notebook running inside the Docker container. PyTorch is now ready to use. First, we will create a new Python notebook in Jupyter. In the first cell, let's import PyTorch and print its version to confirm the installation. Now that we see the PyTorch version printed, it means we have successfully installed PyTorch. Next, let's create a simple PyTorch script to ensure everything is working correctly. In the next cell, let's create a 2x2 tensor, perform a matrix multiplication of the tensor with itself, and print the result. Let's take a look at the result of our simple PyTorch script. In matrix multiplication, each element of the resulting matrix is the sum of the products of the corresponding row elements from the first matrix and column elements from the second matrix. Here's the breakdown. Element 0, 0 is calculated as 1 times 1 plus 2 times 3. The value is 7. Element 0, 1 is calculated as 1 times 2 plus 2 times 4. The value is 10. Element 1, 0 is calculated as 3 times 1 plus 4 times 3. The value is 15. Element 1, 1 is calculated as 3 times 2 plus 4 times 4. The value is 22. So, the resulting matrix is 7, 10, 15, 22. This confirms that PyTorch is functioning correctly, and we can now use it for more complex operations and machine learning tasks. Next, let's perform an element-wise addition with two one-dimensional tensors, one with values 1, 2, 3, 4, and the other with values 5, 6, 7, 8. This script adds each element of tensor A to the corresponding element of tensor B, resulting in tensor C with values 6, 8, 10, 12. Next, let's perform an element-wise multiplication. This script multiplies each element of tensor A with the corresponding element of tensor B, resulting in tensor D with values 5, 12, 21, 32. And there you have it. We've successfully created tensors, performed element-wise addition, and element-wise multiplication using PyTorch. These basic operations are fundamental building blocks for more complex tasks in machine learning. PyTorch is a powerful framework designed for more than just simple tensor calculations. It's widely used for developing and training neural networks, which are the backbone of many modern machine learning applications. With PyTorch, you can create complex models for image recognition, natural language processing, and even reinforcement learning. Its flexibility and dynamic computation graph allow for easy experimentation and debugging, making it a favorite among researchers and developers. In this video, we set up PyTorch in a Docker container, ensuring a consistent and isolated environment for our machine learning projects. Stay tuned for our next video, where we'll dive deeper into the practical applications of PyTorch, including building and training neural networks, and harness its full potential for your projects. Thanks for watching.
Stay tuned for more videos on TechInFive.